Hi, everyone. Welcome to the second R lesson. So today we're going to be kind of covering what we need for this week's homework, which is doing t-tests and annotating a conditional mean plot with p-values so that your reader or whoever you're presenting this graph to can see at a glance both the difference in means between the two groups that you're comparing the outcome variable for, as well as if that difference is significant and at what level, right? Which is the information that we learned this week the p-value contains. So I've already opened up RStudio as before. We kind of have our clean area here. And this week, again, we'll be using the BRFSS, the Behavioral Risk Factors Survey, to look at the number of days per week someone is drinking alcohol, kind of continuing the example from last week. Okay, so what do we need to do first, right? Well, as usual, what we're going to want to do is first attach our package tidyverse. Okay. One thing that I mentioned last week, and I'll mention again here, is when we click tidyverse, we can see that in the console, this bit of code pops up and is executed. So if in the future, when you kind of run your script, you don't want to have to manually click tidyverse, you can simply insert that bit of code as the first line in your R script, right? Another thing that I did last week, but I didn't kind of explain what I was doing, is put code that starts with these little hashtags on a line. This is comment code. So when we put this in and we run it, nothing happens. The hashtags mean that this is just a comment. This is just for the creator of the script or whoever's looking at it to understand, what is this script doing, or what is a particular line doing, or really any kind of annotation that you might want to make. Okay. So we have tidyverse. The other library that we want to include is ggplot. So I'll go ahead and include that as a line of code here. Run that. So that'll be attached to. And we can see in the bottom right, when we search for ggplot, now that's actually been checkmarked as well, right? So these things do the exact same thing, checkmarking it or kind of including that line of code and running it, okay? The second thing that we want to do is read in our data, right? And last class, I showed you how to do that by going File, Import Dataset, going from text, selecting the second option, that was important, finding our data, wherever you stored it, and now notice, like, this is exactly as before. In the bottom right, you can see this thing that says code preview. So this is saying this is the code that is going to be run when we do this kind of import command, right? So if you want to just stick with importing the data like this, by going File, Import, et cetera, totally fine. If you do want to include it as part of your code, you can copy paste this stuff into your R script, okay? So what are the components here? There's this thing that says library reader, okay? This is actually included in tidyverse. So we actually don't need to include this if we kind of just want to kind of have a line of code in our script. This is read_CSV, and this is accessing the file location where our data is, so kind of the complete file. If you're on a Windows machine, it looks something like this. If you're on a Mac, it'll look slightly different. Either way, kind of this is what you want. And then it has this line view. Oh, sorry. And notice here, it will automatically assign this data set, BRFSS 2018, to a variable to kind of like a a placeholder name, which is just the name of the data set wherever it lives, okay? One thing that I kind of didn't say last week is that this is kind of our assignment operator in R, this little kind of left pointing arrow. So this is saying kind of whatever's to the right of the arrow, I want to assign it to this variable name, okay? All right, and then of course down here, view, that's just going to bring up the data set in kind of a different tab so that we can kind of look at it the way it's presented here. So let's copy paste this bit of code, put it here, run this, and you can see, you know, parsed with these particular columns, and it's appeared in our top right. So again, like the advantage of kind of having it in the script is that if you ever just want to open up your script and start working very quickly, you can just, instead of kind of going through the motions of checking things off and using your mouse, you can just run these lines of code. Okay, perfect. So we've read in the code, we've loaded up our libraries. What do we want to do this week? I guess the first thing that we want to do is run a t-test. So compare, you know, two conditional means, see if we can reject the null hypothesis. Sorry, two conditional sample averages, see if we can reject the null hypothesis that the conditional means are identical. Okay, so we have a very simple command for that. But first, remember, we're going to need to clean our data, right? So again, we'll kind of create this new data set or this new variable to hold the cleaned data, where we'll filter the RFSS 2018, and we'll only take these complete cases to drop those NAs, the missing rows. And because we're working with this alfday5 variable, remember there were values of that variable that looked strange, right? So remember, we can kind of look at alfday5. That's the variable name, right? Yeah, alfday5. We can look how many instances of each value there are. Yeah, and remember we have this kind of 899, right, which is a bad number. It doesn't mean anything. It means kind of that this is a missing observation, or someone said something that was not missing but kind of coded as a weird thing. So we need to filter out those responses. Filter out from our kind of already filtered data. We'll do another filter where we only want alfday5 less than or equal to 7. Right. Perfect. Okay. And so now we can run our t-test to compute our p-value. So, you know, the hypothesis we want to test is, does the number of days per week that someone is drinking or has an alcoholic drink differ across genders, right? So we look at our data, we have alfday5. Let's look at our cleaned data, actually. We have alfday5, and then we have sex1, where 1 is for female, 0 is for male. So to do that conditional means test, first I'll show you the quick way. The command is t.test. So one thing, if you're ever curious about a command that I tell you, you can just run question mark followed by that command. And in the bottom right, it'll bring up the help tab and tell you exactly what that does. Okay. So it'll kind of tell you how you should be entering things. And what we can see here is that we have t.test for class formula. So we can put in something called a formula and then our data set. Okay. So how does that look? So a formula in R is kind of a special sort of set of set of characters that R parses. And usually a formula, we're going to be dealing with these kind of all throughout the course. So it's good to kind of learn these now. There's going to be kind of a y variable and an x variable or multiple x variables. And your y variable, in our case, alk day 5, our outcome variable, is going to be separated by a tilde with our x variable. In this case is x1. So R recognizes this as a formula where we have our y and we have our x, and we're kind of saying like, group our y's, kind of take those conditional means of alk day 5 by the different groupings in sex1, okay? And our data is going to be this DAT. So if we run this, we're going to get some output. Let's see in the console, Welsh 2-sample t-test. What can we see? We see our t value. So that's our t-stat actual, 61.2, very, very big. That's going to lead to a p-value of 2.2 e to the negative 16. So basically 0, right? So what does this mean in words? The probability of observing a conditional mean difference as big as we did in our sample data, given that these two groups have the same kind of drinking per day, is basically 0. So if the null is true, if these two groups really do drink about the same amount per week, the chance of observing the difference that we did is close to 0. So we would have to draw on a crazily weird sample to get as an extreme a difference between these two groups as we do here. So that could have happened, but the chance is extremely low. What's more likely to be the case is that our null hypothesis is wrong. Okay. So that's our t value and our p value. Right? We have our 95% confidence interval. So we can see that this is the left confidence interval and this is the right confidence interval. And then we have our two sample estimates, right? Here's the mean for group 0, that's men. Here's the mean for group 1, that's women, right? So these two things look very different in the sample, and we can conclude, the probability that we would have had such different means for these groups if they were actually the same, kind of the chance of drawing such a strange sample that they would look so different if they were actually the same in truth is basically 0. So we reject our null hypothesis. Okay, and that's it. That's the whole t-test. That's kind of understanding all of the output here. We can look at other variables like, flu shot 6, for instance. I don't think it's very meaningful to think about, okay, does the drinking number of days per week you spend drinking differ by whether you have a flu shot or not? But, maybe someone does think that that's interesting. So we would use the same outcome variable, but we would just use flu shot 6 as our kind of x variable. We can see, all right, there's a t value is still large, so our p value is still quite small. True difference in means is not equal to 0. Confidence interval still doesn't overlap 0, so 0 is not a kind of null hypothesis that we would fail to reject. 0 is a null that we would reject. But these means look fairly similar. So is it really that meaningful a difference? No, and this is kind of where our economic or marketing or even just kind of psychological intuition takes over. Is getting a flu shot a meaningful way to kind of explain the difference in alk day 5? All right. So the next thing we'll do is actually compute the t-test by hand. That is to say, kind of using the conditional means, the conditional standard deviations, and the conditional sample sizes from the data, just to kind of show that what's going on in the background of this formula is all kind of kosher. So let's take a look. So what do we need to do? We need to recover the means, standard deviations, and sample sizes. We're going to group by our x variable, and then we're going to summarize. And what are we going to summarize? We're going to get the mean of alpha day 5. We're going to get the standard deviation, which is SD alpha day 5. And then we're also going to get the counts, right? Those two, the sample sizes of those two groups, sex1 equals 1 and sex1 equals 0. Let's run that. What do we have here? 0.932, 0.513, and then our standard deviations, 1.84, 1.36. These standard deviations are the standard deviation of y. They're not the standard deviation of y bar. They're not standard errors. They're the standard deviation of y in that subgroup and the standard deviation of y in the other subgroup, okay? So we have all the numbers we need. So if we were computing our t-test by hand, we can take, so usually what's common is to take conditional mean of y at x equals 1 minus the conditional mean of y at x equals 0. So we're going to have 0.513 minus 0.932 divided by the square root of what? 1 over the sample size of the group where sex1 equals 1, which is 140,990 observations, times the standard deviation squared, 1.36 squared, plus 1 over 99,773 times standard deviation squared, 1.84 squared, right? All of our brackets seem to be lining up. Run that, that's negative 61.08, right? Remember, our t-stat is always positive. So that's our t-stat computed by hand. And here is our t-stat computed by the machine, 61.2 versus 61.08, pretty close. Why is there a little bit of a discrepancy? It's kind of not worth getting into, and it's not really going to matter. But in this case, we can kind of see that there's basic agreement between these two t-stats. So what R is doing in the background with this command is what we're kind of doing with this formula that we learned in class. Okay, perfect. So last bit for today, we want to plot the conditional means and then put the p-value on there so that we can kind of see at a glance, what's the difference in means and is it statistically significant? So like with last class, what we're going to want to do is create a new kind of small data set. Call it graph.dat. And this small data set is going to be these two conditional means, right? So we're going to have remember that we want to name alpha day 5 here so that we can access that new variable in our little data set, graph.dat, right, which has appeared in the upper right in our environment. And we have our two values for sex1 and then our conditional means for alpha day 5. Okay. Perfect. So we have our little graph data set. Now we can use ggplot. G on bar as before. X is sex1. Y is alpha day 5. And we want kind of this proportion, right? Or sorry, no, we wanted to just kind of use the values that it sees in the data set in this little graph.dat. We want to use those y values as the y values that we're plotting. So we have stat identity. And now for adding the p-value, we're going to use this annotate command. So our annotate command we're going to have a text style annotation, right? We're going to put in our p-value. We need to specify where we want this annotation to appear on the graph. So we'll play around with these values in a bit, but right now I'm just going to put x 0.5. It's halfway between sex1 equals 0 and sex1 equals 1, so it should kind of appear in the middle. And then y equals 1.5, so it should kind of appear above. And then our label, if we have a text type annotation, it's going to be looking for a label. The label here is going to be, p-value less than 2.2 e to the negative 16, right? That's what we found. And then some sort of stylistic choices, size equal 5, color equals red. We'll see what playing around with those does. Okay, so let's run this. And here's how that looks, right? So for women, we can see the number of days per week spent drinking, or number of days in the past week that they had an alcoholic beverage is the mean that we've calculated many times now. And then for men, it's higher. And the p-value, the difference between these two things is very, very small. So we can reject the null that these two means are equal. Okay. As usual, we kind of want to present this in a nicer way, in a way that looks professional and more easy to understand. So what is that going to mean? It's going to mean labels. It's going to mean colors, and maybe a different theme that looks less gray. Okay. So we can mutate GraphDat. And we'll say this new variable male is equal to or rather female is equal to female if sex1 is equal to 1 and we're female, here we go, and otherwise we're male. Okay. And then alk day 5, we don't need to kind of change the name of that. We can just change the axis label. Okay. So let's put this up here. And now instead of using sex1 as our x variable, we'll use female. Okay. So now we have female, male, instead of, sex1 equals 0, sex1 equals 1, which was less informative. We do see that kind of our annotation has kind of gotten away from us. So let's set x equal to 1.5 and see if that fixes it. Yep, so now we're back in the middle. We can probably squeeze the y down a little bit too, so we don't have so much dead space. Very good. And now that we have the female male, the x-axis label is redundant. So let's just make that empty. And our y label is days per week. That's kind of cumbersome, but let's just go with that for now. All right, so that's looking pretty good. Let's set our theme to something nicer. Perfect. And yeah, as I showed you before, we can also kind of set these two things to be different colors. So if we want to do that, we can specify in this geom bar, AES, this stands for aesthetics. X is our x-axis, y is our y-axis. For colors, we say fill, and we want female to have a different color than male. So our key variable for this fill is going to be female. And then we have stat equals identity. That's still good. When you do fill, when you do a color, R is automatically going to add a legend. So let's see what that looks like. Now this is obviously super redundant, right? Female, male, like we already have all the information from the labels. The color is just to make it kind of nicer to look at. So we'll get rid of the label, the legend, by adding in kind of another theme specification, theme parameter, and legend position is going to be equal to, I think it's just empty. See if that works. Yeah, so that got rid of it. Okay, so now this is looking pretty good. This is looking fairly presentable. We can stop here. All right. Everything past the annotation, this is all just aesthetics. And the fill is also aesthetics. But yeah, I really encourage you to kind of start thinking or keep thinking hard about how you should present your graphs in order to convey the most information, convey the important information, without your kind of reader having to do a lot of extra thinking, right? Perfect. So that's all we have for today. So this should be good for you guys for your homework. If you have questions about R, and I'll mention this in class as well, come to the tutorial where, it's online, but like we'll do share screen. We'll kind of go through R coding questions if you have questions. Office hours are also a great place, right? And that's Thursdays from 4 to 6, also on Zoom. And there's a link on the course webpage on Quarkus. All right, great. So good luck on the homework, and I'll see you guys next week.